So you'll see here there are four suggestions on how to solve these problems. These are not rules, these are not steps, these are suggestions. So when you ask me for help, I'm likely going to ask you, did you try those four suggestions? And if you say no, then I will say I will not help you. So suggestion 1, these are in random order. Transform the more complicated side of the equation into the form of the simpler side. Suggestion 2. Substitute one or more basic trig identities to simplify the expression. 3. Factor or multiply to simplify the expression. You're going to love it when you have to factor. 4. Multiply both the numerator and denominator by the same trig expression. Those are 4 different suggestions. Number 1. What's nice about these, what's better than this, than what it was in the simplifying ones? This one you know when you're finished. Simplifying, you don't always know when you're finished. For these, when it says verify it's an identity, it means make the left side and the right side say the exact same thing. You can work with the left side, you can work with the right side, you can do a little bit of each. I suggest working with one side till you get stuck, then working with the other. So, number 1, here's what I see. This right here looks very familiar to me. Does it look familiar to anybody else? It's part of one of the trig identities. Let me explain. This is called side work, so I'm going to do it off to the side. Sine squared of x plus cosine squared of x equals 1. That's the Pythagorean identity, the first one. If you were to get sine squared by itself, by subtracting cosine squared from both sides, you would get this, which is the same thing as the right side of the equation. Do you all see that? So you do the little side work like I did it there, and then on the right side of this equation you can just say, well, this here is sine squared of x. I think you would agree that the right side is pretty simple right now. Since that's pretty simple, I'm going to go back to the left side and see if I can change it in some way, shape, or form. One of the suggestions that I gave you, not on this paper, but the other day, I think the only suggestion I gave you, is when in doubt, change things to terms of sine and cosine. Tangent squared of x can be written as sine squared of x divided by cosine squared of x. And then we already have a cosine squared of x over here. Hopefully you can see that the cosine squareds cancel because you have one on the top and bottom of the fraction. Now we're finished because the left side says the exact same thing as the right side. Your answer is not that last statement. Your answer is the whole thing. Somebody else can have a completely different last step than you have, and theirs be correct as yours is correct. So you'll notice in the homework there's no answers for these. It's right when you get the left and right side to be the same. Questions on number 1? Pardon me? I think you're referring to this part right here. Is that correct? If you notice over here, 1 minus cosine squared of x is the same thing as sine squared of x. We just replaced it. Number 2, It is my opinion that the right side is the more complicated side because it is really complicated. The reason that I believe the right side is really complicated, there's addition there. And when I see tangent and cotangent, I usually don't see tangent and cotangent. I see fractions. And adding two fractions is very complicated. What would cotangent of A be using the advice that I've given several times of changing things to be in terms of sine and cosine? Cosine of A divided by sine of A. What would tangent be in terms of sine and cosine? Sine of A over cosine of A. Once you've done something like this, or once you have something like this where you have two fractions you're adding together, you need to add those fractions together. I'll say 99% of the time if you have two fractions, you add them together. To add two fractions together, you need common denominators. So the first fraction, you need to multiply the top and the bottom by cosine of A. Cosine times cosine is cosine squared, leaving the bottom with sine of A, cosine of A. Multiplying the top and the bottom of the second fraction by sine to get common denominators, you're going to get sine squared over sine of A, cosine of A. I consider this red step and the step after this being on autopilot. It's something that you just automatically do. You don't have to do any thinking, hopefully. You just get common denominators and add them together. Once you have common denominators, you add the numerators together. Cosine squared of A plus sine squared of A. Your denominator does not change when you add or subtract. Once you've added your fractions together, then there should be some type of identity or canceling that you could do. Does anyone see an identity we could use or some canceling that we could do? Cheyenne? The top is 1. That's the first Pythagorean identity. Up to this point, I didn't even look at the left side. I just changed the right side to sine and cosine, added my fractions together, used an identity. At some point, and perhaps we should have at the beginning, keep glancing over to the left and say, how can I get this right side to be like the left side? We're at that point now where the right side is pretty simple. Any ideas how we can get the right to be the left or the left to be the right? Pardon? Please do not use the term inverse because I do not think that you know what it means. Reciprocal. What's reciprocal of sine? What's reciprocal of cosine? That is identical to the left side, so we are finished. If you don't change a side, then you don't need to write it down every time. So I didn't change the left, so I just left it blank, meaning it's the same as the top. Questions? Okay, number 3, ladies and gentlemen, which side do you think is more complicated? Because my suggestion, one of my suggestions was make the more complicated side, work with that side first. Make it less complicated. Any suggestions on the left, something we can do? That's right, the top is secant squared. That's one of the Pythagorean identities. Any ideas from there? somehow that whole left side becomes tangent, because that's what the right side says. Provocative, thought-provoking. What's the only advice I gave you yesterday and the day before? Katie? Okay. So we can change secant squared of b into 1 over cosine squared of b. Sometimes you got to make it more complex to get it more simple. Cosecant squared of b is 1 over sine squared of b. Now this is another autopilot moment. You have a complex fraction. You don't ever want to have a complex fraction. So what you can do to fix it, take your numerator, multiply it by the reciprocal of your denominator. Still on autopilot, because if you're multiplying two fractions, you multiply the tops and you multiply the bottoms. Gives us sine squared of b over cosine squared of b. Keep glancing over to the right. What are we trying to accomplish? We're trying to get tangent squared of b. And we have accomplished that because that is one of the quotient identities. The left side and the right side are identical.
Wait, I thought, it doesn't matter if they're squared, right?
It does not matter. It's correct. This next problem, I would say at the very beginning, you should be on autopilot. What should happen on this next problem? I believe it's phi, sir. Factoring, GCF, greatest common factor. Why do you want to get the same denominators? Right, you have two fractions that you're subtracting. You want to subtract them. So you want to get common denominators. On the left, you want to multiply the top and bottom by cosine of phi. Phi, phi, pho, fum. I smelt the blood of an Englishman. The right fraction, you need to multiply the top and bottom by sine. Sine times sine is sine squared. I believe it's phi. Somebody sitting at a computer at home right now is screaming at their monitor that it's not phi. And I say to that person, get a life. Just kidding, person at home. Once you have common denominators, subtract your fractions. So autopilot is finished. Now comes some thinking. I don't think you should use the word opposites because I don't think you know what it means. What does it mean when you multiply two reciprocals together? You get 1. A number times its reciprocal is always 1. So cosine of phi times secant of phi is 1. It's my duck. It's my pet duck, Reggie. It's a timer.